we are taking derivatives, and we're going to want to take the derivative of what's in the brackets here, and that's what the d over dx tells us to do. So we have 2 sine x over 3 roots of x squared plus 1, and I'm claiming this is going to be what our derivative is equal to. Now what we're going to want to do here is get this out of radical form, get it into exponential form. Because this is 3 roots, we're going to raise this whole thing to the 1/3 power. Now I'm going to want to use the quotient rule, so I take the derivative of the numerator, and the derivative of 2 sine x is going to be 2 cosine x times the denominator minus the numerator times, and then this is all the derivative of the denominator. So we take the 1/3, bring it out front, rewrite what's in parentheses, subtracting 1 from the 1/3, so 1/3 minus 1 is negative 2/3. And then we take the derivative of what's in parentheses and bring it out. So the derivative of x cubed plus 1 is 2x. And then it's all over the denominator squared. So now we are back to working with algebra again. So we want to try to clean this up as much as we can. Alright, and so what I do here is it's looking like I'm factoring out. Let's see, there's a 2 occurring over here. We got a 2 over here. Actually, there's another 2 over here, but yeah. So I pull a 2 out. I pull out a 1/3 also. We have a 1/3 in here. I'm going to go ahead and factor 1/3 out. I'm going to factor an x squared plus 1 raised to the negative 2/3. And remember, we have x squared plus 1 occurring over here and x squared plus 1 occurring over here, but this is to the negative 2/3 and this is to the 1/3. We always factor the one out that has the smallest exponent. So that means we're going to pull this negative 2/3 one out of there. So that's what I do. And then I start with a bracket here, because sometimes if you put a parentheses here and a parentheses here, it just kind of gets you confused. So I put a bracket, and we pulled out a 2. So that's the reason there's not a 2 in here. And we pulled out a 1/3. Now, the reason there's a 3 here, because think about this. If I take the 1/3 and I multiply it by the 3, I just get 1 left. Alright, since there's not a 1/3 in here, but if you throw a 3 in, you can pull a 1/3 out. It sounds kind of complicated, but it's not too bad once you get the hang of it. I have an x squared plus 1 to the first power. Because I pulled out a negative 2/3 out of here, out of this 1/3, we're left with just a 1. Think about this. Negative 2/3 plus 1 gives us 1/3. Now over here, let's see, we pulled the 1/3 out, we pulled a 2 out, there was still another 2 left, so we had to leave it there. And of course there was an x, we didn't pull any x's out, and then we had the sine x. And of course we pulled all of this out front. And now what I'm going to do here is look like I have this x squared plus 1 raised to the negative 2/3. We want to write everything usually with positive exponents. And so I'm going to take this down into the denominator, so it becomes a positive 2/3. And I'm going to take this 3 here and also bring it down, because this is a fraction here. We can bring that 3 down into the denominator, leaving the 2 up here. And it looks like I'm just not doing anything with that. And because we have an x squared plus 1 and x squared plus 1 to the 2/3 to the 2/3, so we just add their exponents. So 2/3 plus 2/3 is going to be 4/3. And I think that's where I stop. I think I'm done. Okay, so we did a lot of factoring in this problem set, and it's something that you really got to get down. And we did a lot of fractions also. So got to get that stuff down. It's very important. It just makes life a whole lot easier once you get that down. Calculus is pretty much a breeze when you get the intermediate algebra steps down. So there we go. Final answer.